Okay, so now we're moving on to the part of the question where we're asked to examine the stack here and make some deductions about it. So the first thing that we should do in order to be good stack detectives here is redraw our expected stack frame that we had from before. So before we said that the kind of pattern that we want to look for when we're looking at this stack down here is we expect to find some y argument, and then an x argument, and then an old LP from that push LP, an old BP from the push BP, so this is the entrance sequence for the f function, and then the base pointer is going to be here because of that move SPBP, and then we push the callers R1 and R2. So that's going to be old R1 and old R2. Alright, so now we're told that this procedure is called from some location, FC, and its execution is interrupted during a recursive call just prior to the execution of the instruction tagged XX. So the place where this guy gets interrupted is right here, right after this deallocate. So now we want to know what the arguments to the most recent active call of F were. So that means that it finished with this recursive call, and it finished with this recursive call. So now we're trying to figure out what the arguments were. So we know that the BP's here. Given that that's the BP, this must be the old BP. This must be the old LP. And then right above that, we should have had X and Y. So right here, these are the arguments to the last active call. So X is 0, and Y is B. Okay? Now we want to know what value is stored at location 478, which is shown as question mark here. So because we know, just crawling back up, this was the beginning of some, the last frame, and then 1, 2, 3, 4, 5, 6. Right. Alright, so these are our frames, so then we can start figuring out what happened the frame before. So this is old R2, old R1, right? And then this would have been the old BP. Right? And then the X and Y for this frame. So BP points to old R1. Okay, so now this BP and this is old BP. So 1, 2, 3, 4, 5, 6 lines up, right? We expect to find the next BP. And then this guy is always saved in the line above that one. So here is the connection between the current BP and the old BP. And then 6 lines up from the current BP in that frame would be here, right? That was the BP from the frame before we decided on. So that would be the thing that gets saved over there. Okay, so the answer here is going to be 4, 6, 4. And what are the arguments to the original call of F? Well, using the same BP logic here, this guy, this D4 value, is not a value that's 1, 2, 3, 4, 5, 6 values up, right? These two are not equal to one another. So because of that, this must be the caller's BP from whatever function called F to begin with. So that means that this must have been the frame from the original function call. Right, so 1, 2, 3, 4, 5, 6 lines. Okay, so then we have y and x, so y is 3 and x is 2. Okay, now we want to know what value is in the LP register when this thing stopped. Alright, so next we're asked to find what value is in the LP register. Now this one, we know that when we look at the original function here, because we have two recursive calls, we're going to see two old LP values in the code. Alright, so 50 is smaller than 70, so let's say that if this recursive call went, then the value saved in LP would be PC plus 4. So that means that this would be the place in memory where that deallocate is. And then 54 would be the place where the load is. 58 would be the place where the add is. 5C would be where the push is, and then 2 instructions later, right? So 6064 is the next one. 2 instructions later, so 686C. And then the PC plus 4 during this recursive call would be 70. So sure enough, 50 and 70 are two old LPs, so that looks pretty good. And we know that we halted just prior to the instruction of the execution tag XX. So that means that this one must be the recursive call that we just came back from. So that means that 70 must still be an LP at this point. Now we want to know what value was in R1 at the time of the original call. We know that we said that this is our original frame right here, and this is the old R1, the first time we got called. So that was in R1 the first time we got called. 3, right there. And then they say, what is the value currently in R0? So to figure this out, we need to be a little bit clever, and we need to look at our code again. This is going to return y. This was y plus f of a and b. So whenever f is run, if it doesn't recurse, in other words, if it goes back up the stack instead of continuing to recurse down the stack, then we know that it's returning the second argument. Okay? Because that's what it does right here. It returns the second argument whenever it does not recurse. So because of that, we can be clever. And at the time here, we want to know what's in R0. Well, we know that this would have returned the second argument to the function, which was b, right there. So that must have been what the recursive call returned, was the second argument, because it's going back up the stack. And the reason we know it's going back up the stack is because it's done with the recursive call and it's doing this exit routine. Okay? So we know that the value in R0 has to be b. And last, we want to know what the hex address is of the instruction tagged WW. Well, we kind of figured that out before, right? But the thing that this question wants to test and make sure you remember is that push is really 2 instructions. Remember that macro involves incrementing the stack pointer and storing something. So because of that, we can reference from whatever LP was, which is here, right? We can just count backwards to what the push was. So we did that before. So that's just 6-4. And we're done.